Welcome back, guys. This is Legit Lee back again with another video. Today I want to talk about this 3D printer that I designed from scratch here. It's based off of the CR10, so you'll see similar parts. Like I have these brackets I got from Banggood. They're CR10 or Creality Ender stuff. And the stepper motors are actually from an ANET A8 3D printer, other than the one on the back, which I have. That one is a used NEMA 23 to move this huge heavy plate. So I want to talk about really is my quick disconnect features. So I have multiple tools ready to go at any given time that I want. And this design is actually off of a guy that I watch on YouTube called Proper Printing. I subscribed and even message him every now and then. So I have multiple tools here. I'm going to go over all of them. And sorry about noise in the back. I live with family, so you guys have to bear with me here if there is any extra noises in the background. So I want to talk about all these tools I have here. So first we're going to start off with my HotEnd, because basically 3D printing is just that, using a HotEnd to melt filament and build it up. So we're going to talk about this X carriage here. This X carriage was designed by Proper Printing. It's based off of a camera tripod. And basically it uses this V-mount system that just locks into place, and then it locks, literally locks. So it slides into this groove and then it locks itself into place where it won't move. So it works out great. I made all these attachments based off of his information, so none of these are his specific designs. I had to tweak and make my own. Even the one that he had for his laser engraver didn't work for my laser engraver because his is from Creality and mine isn't. I bought this one. This is a 5-watt laser engraver, way more powerful than what he has. And the reason why I say it's different is because his mounting holes were a little more pushed in, mine were a little more spread out, so I had to design me a bracket that worked for my stuff. So I can just add this bracket in here, and now I have a laser engraver. Works out great. And it uses a barrel jack connector here. So if I wanted to, I can just plug it in. And this is going over to the fan port for your blower fan of your 3D printer on my motherboard. And I'm using a MKS Gen L version 1. That motherboard works out great. I recommend it to anybody. So I'm using that right here to plug in for my my laser engraver and my HotEnd. So if I wanted to, this information here is from Tech2C. Appreciate it, man. This is a quick disconnect that I got offline. It's based off of hobby RC cars, and it uses 6 pins, which is 6 wires, which is the HotEnd. So a fan for 2 wires, the heater cartridge is 2 wires, and the thermistor is 2 wires, so 6 wires altogether. And with me having a blower fan connected to this barrel jack, it works better for this scenario that I have. but it probably would work better if you can find yourself an 8-pin connector if you want to use the fan blower as well, if you want to quick disconnect that. But mine is set up decent. All I have to do is just plug it in. It's hot glued on the back to this barrel jack female connector, and the wires just go up in there. I screwed them down to the terminals. Works out fantastically, and I'll just plug it in and slid it on the slot, and there you have it. So I had to design that whole entire piece. This piece I designed a while back, but I need to redesign it so it can fit this connector part in, and then I can just kind of glue it into its own little slot. And then the back piece I had to design as well, something like this for the HotEnd, because proper printing uses the HotEnd that comes with the CR10s or the Creality series printers, so it doesn't use a V6 Bowden tube style like I have right here. I had designed that part myself, and but it works out fantastically. You have no issues. You just have to make sure that you configure your Merlin software for the position of the, to dead center. So I have videos up on that, so if you guys want to check that out, you can. And but I have printed out this bracket 4 times, one for each HotEnd holder, tool holder, so I can just place the V6 HotEnd right here, lock it into place so I know exactly where it's at every time. And the same thing for any of them. So this right here I designed again. This is a plotter drag knife. I bought 2 of these. I bought one from China. If you want to get one from China, it'll only cost you $5. And it comes with a bunch of drag knives on the tip, the cutter blade. This will be for any vinyl cutting. This is what this is for. It's vinyl cutter stuff, so I can vinyl cut or print out or cut out flexible PCBs. This is a M0 Trinket Adafruit microprocessor PCB that I designed for one-sided PCB, and so I want to make it flexible. I'm going to be designing and talking about that in nearby futures, but I'm not going to get into it on this video, so I'm trying to hurry up here. But it locks into place just like any other one, and then it will cut out anything I want, whether it's vinyl or on, basically aluminum or copper tape. So we have that. And then I have another one that's strictly for basically pens. So if I want to draw a picture out, I can use this one. So a Sharpie or any fine tip pen, I can just latch on, bam, we're good to go. My last one, which is going to be talked about, because this one is going to be a little longer of a speech because there's a lot of information about just this one. So Tech2C, which I appreciate the information, man, thank you for all the videos. He talked about his setup for his Hypercube 3D printer. So his Hypercube 3D printer uses a Dremel like this. Not this one specifically. He has a rotary tool Dremel, and but he was having issues with his Z-axis movement. He said that his wand, his holder, was moving on the X. It will allow it. It was too much play up and down, about a good 2-3 millimeters. It seemed like when I was watching the video. So he went with this right here. This is actually it's not a rotary tool. It's actually, I mean, it is, but it isn't. It's called a grinder tool, and they use this for basically jewelry, cutting diamonds and like fine tip working and stuff. So they would get a motor with this tool, and then it change out the heads for this, and it works out great because you can actually just use the key and a chuck just like you would for a regular drill that you would buy, and you can actually take out the bits. I designed this whole part myself as well. It latches on here without any issues. Now the reason why I want to talk a little bit about this one is because of how I found it. Now Tech2C got his from Banggood, which is a company based out in China, so it takes about 3 to 4 weeks depending on where you're located at. And I didn't want to wait that long. I was like, man, I really want to get this going. That could be a great asset to my printer, right? So I was looking on eBay, trying to see if I can find anything that'll be like this where I can just buy it off somebody. Then I found one that was from Chicago Electric that had the same setup, same everything. So I was like, wow, Chicago Electric, I know that company. It's from the actual company for Harbor Freight. They're like interweaved, I guess. I don't know if they have rights to them or what, but I know they sell all their stuff out of Harbor Freight. And I love going to Harbor Freight. That's my store. I buy all my tools there for the most part. other than like Lowe's or something, and maybe occasionally Home Depot. But anyway, so I was like, wow, you know, like Chicago Electric, I should just check to see if they have it. So I looked on Harbor Freight. Turns out they did. Went down to my local Harbor Freight and picked up this whole setup here. So this motor is a Chicago Electric brushed motor, and it spins at, I think, like 15,000 RPMs or something. I can't remember the speed, but it's fast. It's definitely fast. And it came with everything you see here other than this chuck here, the bit. So this one is actually better in my opinion because of the fact that Tech2C bought his from China and it was all metal based. Mine is actually made out of aluminum, so it's lighter, it can move faster, and it won't weigh down my setup here too much. So all I have to do is just place this in, pop the chuck in, and then it will spin as fast as this motor would spin. And I have this set up right now this way, but I will be setting it up better. I don't like this setup, so don't pay any attention to this, but I will have, you know, filament roller better, and I have a filament runout sensor that I need to add to all this, and then the motor needs to be straight up so it won't have any bend or curves inside of the flexible shaft, because we want to make sure that the flexible shaft doesn't rub up against itself so it makes it hot or slows down the speed of the Dremel here. So I know I have to tweak and design that. That's just baby stuff down the road, but I just wanted to let you guys know it does work fantastically. I actually cut this piece of plexiglass because I'm making a 6-axis robot arm, and so right now I have printed out this piece. It can attach another arm basically to move, and but I'm not using this piece. This was just a, you know, test cut, and but it worked out great. I used Tech2C's information for cam design cutting through Fusion 360, and it worked out great. My passes were a lot more because I was trying to get finer detail. These circles right here are 22 millimeters circle diameter, and that's because of using skateboard bearings to, you know, position everything and be able to move smooth and fluently. So I have that cut out, so it does work great, and so it can cut plexiglass, it can cut wood. I haven't tried aluminum yet. I would like to, so I may in the future, but right now I do know it can cut those two things for sure. And then with me using, you know, my drag knife, I can actually cut vinyl if I want to, or draw on pieces of paper if I want to, and I could 3D print. So literally this printer can do pretty much everything I want it to do. So back to this though. My Tech2C was talking about how his Dremel wasn't working right for his stuff, but mine actually works fantastically. I didn't know. I was at Lowe's and I was like, man, you know what? Let me just go ahead and pick this up. It was $20, had it on clearance for this flexible shaft. So I picked it up and it works out fantastically. Mine doesn't have any place, so his wasn't a legit Dremel tool. His was just a rotary tool. So if you get the Dremel one, you shouldn't have any issues. So I would say get the Dremel with the flexible shaft, and you won't have any play whatsoever in your stuff. I designed this other piece. That's what I'm trying to get at here. So we'll finish off talking about this piece. So this one I designed using Tinkercad for the most part, and then this design right here, this piece is actually to put a hose in for a vacuum. So this vacuum part right here will just slide right all the way in, and then sucks out any of the stuff that would be cut through this. But it's not great. I want to add like a little brush on here that kind of brushes up the stuff that's sticking, so we can suck everything up. But yeah, I designed this piece and it's super flush. Let me just pull this off. It's super flush here, so it actually forms the shape with this, so it actually works super great. And this gap right here is just so you can see your tube if you want to like push it down. If you're having issues trying to get all the way to the bottom, I got this gap opened up so you can actually get to that spot. So it works out fantastically. Let me just move this now. So yeah, that setup I designed in Tinkercad, and it worked out great. I haven't had any issues, and it's really sturdy and support. I mean, the infill is like 10% or 20%, I forget, but it's using lines. I'm using Cura and using lines instead of like for my infill pattern. So I like the whole cross section stuff. I know that's more durable basically instead of like an octagon and shit. But So next I want to talk about this design. This design right here, I actually designed this whole part. Let me just pull this off here so you guys can see. It's a little tight because it's made out of, the flexible shaft is made out of rubber. So this Dremel piece is made out of rubber, and I designed the whole entire thing in Blender and then exported that out into Tinkercad. I could have done everything in Blender, but it just takes a while for me to figure out exactly where I'm trying to go with Blender. Tinkercad is just like cut, paste, done. So I just wasn't worried about it, you know, just to speed everything up. So I designed this piece, but you can see that this protrudes out a little bit, about I want to say 2 millimeters out of length, because of this little button that you press to hold for it to lock into place to take out any of these bits. So I designed this slot in here and this button viewer. Basically, you can actually press the button while you're in there, so literally it just slides into place. Let me just try to see if I can get this all in the shots. So if I just push it in through that gap, it will go all the way in and then lock right into place. And then if I wanted to, I can screw these in, and you know, it has 4 holes on each side, so 8 bolts or whatever, just to keep it sturdy. And then it will lock right into place on here, just like this. And then there you have it. Now it won't move, and you can actually still press the button to, you know, lock it into place like that, and then take out your bits that you need to exchange out, whether you're doing PCB works or, you know, regular CNC cutting some stuff. So you have the ability to do that, and this doesn't move at all, so you're safe with this one. So tech, if you're watching this, you can still use your, you know, if you get this rotary attachment from Dremel, you can actually use it without having to, you know, use this one if it's too heavy. I wanted to let you know that. So if you are watching this video, if you decide to get a regular Dremel tool flexible shaft, you shouldn't have any issues with the whole flexing on the end of your milling. So you do have that option if you didn't want something heavier for your printer. But I mean, you still have this one as well. I wanted to mention the Chicago Electric one is made out of aluminum for the outer part. The inner part is metal, steel, so that's good. But the outer part is made out of aluminum, so it is a whole lot lighter than the one he has as well. So I would recommend getting that one from Harbor Freight. It cost me 50 bucks, but it came with everything. You have the motor, you have the flexible shaft, and you have the tool, and it comes with the chuck, so you're all good. I mean, you're still going to spend about $20, roughly, a little more, if you're buying it from Banggood with the shaft and just this part without the motor. So, I mean, basically I just spent 30 bucks for the motor, and it came with everything. So, anyway, I hope you guys are liking this video. Please like, subscribe, let me know what you think. I know this video is a little long, and I do apologize. I had to get this information out as fast as I could. But yeah, like, subscribe, hit that notification bell and share button if you really do like my stuff. I will be coming out with more information and videos shortly, within the next few weeks. I want to start Blender streaming, so where I'm working with Blender and like designing other stuff like this. So if you guys want to watch those live streaming, I should start that within the next few weeks here, which will be like on a Thursday or Friday mornings ish. Like I want to say 10 to 11, but I'm on Eastern Standard Time, so you kind of gotta, you know, figure that out for wherever you're located at. But so yeah, like I literally been working on all this stuff. I want to show you guys how I design it, and then with me doing the whole Blender streaming, I feel like you guys would, you know, help me out too if I'm like missing a step or forgetting something. If you're into Blender that hard, I recommend watching those videos too. But yeah, I 3D print, 3D design, and obviously DIY a lot of different things. So if you like any of those things, consider subscribing to my channel. Proper Printing, thank you, man. You're great. Love your design. And Tech2C, as always, you are fantastic, man. And if you guys ever want to collab on anything that I'm doing, please, by all means, just hit me a message. Send me some kind of message in the description, or I'll even give you my email if you decide, you know, if you message me, say, let me get your email. I don't mind. So I'm really trying to look forward to like working with people too in the nearby future, because I want to create something amazing that I can leave behind when I am passed away, to help, you know, stuff like this. You guys help push, you know, technology forward a little bit for people that are like me, that like tech, just don't have degrees to work for a tech type of job. So this stuff right here is, I mean, granted it's a hobby, but it can be worked into making it a business. So obviously, if I wanted to you know, start vinyl cutting stickers for cars, I can do that. If I wanted to cut out little boxes, treasure chests, you know, laser cut, engrave wallets, phones, accessories, whatever, you can actually make a business off of this machine right here. And it is literally used parts. That NEMA 23 motor was used, spent about $20 or so for it. It came with a G2 pulley on it. I think it's a 20 tooth. And then I recycled my ANET A8 threaded rods and not the rods, but the motors, the stepper motors. The rods, I had to buy those separately because of how long they are. But you could recycle them if you're going downscale where it's going to be that high, which is like, I think 250 millimeters high or 230, one of the two, I forget, 240. So you can recycle those if you wanted to make something like this, and just buy the aluminum profiles and, you know, 3D print all this stuff before you take apart the ANET. But you can make it this big and do whatever you want with it. So I don't know the overall cost of all this that I have. $50 for the motor, you know, I forget the price for the excursions, and I spent about like $70 on the brackets from the Creality stuff. With the bed and everything, I want to say I probably spent about a good $400 to $500 maybe, like tops. But this, I won't say all that out at once because it's parts that I was doing. First it was getting the printer just to print, then it was getting all the other attachment tools. So maybe I spent about $300 to $400. I don't really know. I didn't like tally up the pricing, but if you need me to try to do so, I can look into it. If you guys are wondering how much it costs to get something like this going, this build plate right here, I bought this mirror. I like mirrors because printing on a mirror is easier, kind of. I use hairspray to have for the stickiness of the bed, and then mirrors, I like mirrors better than glass print beds because glass can be warped, but you can't see that. Mirrors are always going to be flat. They have to be, because if they weren't, then they're going to be like funny mirrors, like you can go to like Carnival and do, where it's kind of distorted. So in order to reflect correct information, like how you see that tool head right here, it has to reflect correctly, so it has to be completely flat to reflect the right image to you in the same proportions. So mirrors are always going to be better to print on, in my opinion, because they're always going to have to be absolutely flat. And but yeah, the print bed is 16 inches squared. So this is actually a 1/4 inch aluminum plate, and then I have a 400 millimeter silicone heated bed. So that's underneath here, double-sided taped up, and then I have some foam for insulation to keep the heat going upwards instead of spreading everywhere. It just constantly stays up and contained. And so I'm using Bang Bang on the firmware side instead of using, like, you know, regular HotEnd type of firmware. It's using because I have to use AC, which here is 120 volts of electricity, 110 and 120 in America. But I mean, obviously you can get stuff that works for your country, so if you wanted to do that one, you can. I'm just saying what I have on here, and it does heat up pretty quick. I'll say about 2 minutes, 3 tops. It's at, you know, 60 degrees for printing or whatever is usually where I'm at for like PLA and stuff. So and if you see this square, this was cut out of my laser when I was testing out. I forgot to take the mirror off, so it kind of laser cut a little bit. It didn't like cut it out, it just engraved it kind of. But I can always buy another one of these. This is a 16-inch mirror, but I got it from eBay for weddings. It was a wedding mirror, I guess, and I guess it's for like when you set up decorations and stuff for a wedding ceremony thing. They have these mirrors you can buy, and it was $15, pretty cheap. The guys were really nice too, because the first one, this is my second one, the first one came in, it was broken already, so I told them about it. They were happy to send out another one, so thank you for that if you guys do see this, which I don't ever think you would, but nonetheless. The print bed, super great, love it, works out good, rolls nice. Right now it's not rolling super fine because, you know, the belt's on there, but if it wasn't, it would just, it's as smooth as butter, let's just put it that way. And then I have my end stops over here, you know, regular end stops. I don't have Maybe in the future I may do the trinamic stepper motors where you don't need end stops. They just bump into itself and then they know that it stopped right there. So I don't know, but for now I have this setup and I really like it. It works out great. Like I mentioned, guys, I know it was a long video, probably like 25 to 30 minutes, so don't chop my head off about it. But yeah, if you're wondering about these glasses over here, this first one was, I went to see the Avengers Endgame movie, so it was 3D that I went, so I kept the glasses, you know, rest in peace, Tony. And then this one right here is for my laser engravers, the glasses. So I have that for my laser cutting. I will be building me probably in the future for sure a box that will keep, you know, have laser glass in the front, you know, that will keep you from actually looking at it or worrying about anybody else walking into your room or something to look at it, to keep people safe. But for right now, I'm not too worried about it because I'm not doing a whole lot of laser cutting. I'm more doing like CNC and 3D printing and like maybe plotting with the, you know, drag knife. So yeah, man, if you guys have any questions, definitely comment below, please, because there's a lot of information I probably didn't even go over here. I'm just trying to make this video as short as possible, and I'm sorry if it was winded. So, this is Legit Lee, guys, and I am signing out. Thank you.